All right, follow the laser because we're going to move kind of quickly through this. I find this I think this is simple. All of this is also in your ebook or physical book if you want to look this stuff up. But I basically took all of the important bits and kind of put it on here. So we're over here to start off with. So here's some of the vocabulary. Okay, so basically we're going to be talking about probability, and probability is all about, if we look right here, probability of an event is the likelihood that it will occur. We talk about it in percentages, 50% chance of rain, 100% chance that I will be at school tomorrow, although you can never be certain, so um, anyway, you can, but anyway, we'll talk about that later. All right, so an experiment is an investigation or a procedure that has varying results. So an experiment would be um, actually, seeing how many times you flip a head, for instance. If you had a coin, flipping heads and tails. The experiment would be to check it out, hypothesize. I know you guys talked about this with the scientific method. So it's kind of an experiment would be kind of proving a probability, and we'll talk about that soon too. The possible results of the experiment are the outcome. So for flipping a coin, there are two outcomes, heads or tails. For rolling a die, there are six outcomes, 1 through 6. The collection of one or more outcomes is an event. The outcomes of the specific event are called favorable. Okay, so we have an event. We're going to roll a dice. We have an event. We're going to roll a dice. There's six total outcomes. The favorable outcomes would be whatever you call it. So what is the probability that I would roll a 3 out? Well, there's only one 3 on the dice, so therefore the probability of rolling a 6 would be 1 out of a possible 6, and then you would divide 1 by 6 to get that percentage. I'm going to kind of move on here. Okay, rather than figuring that out. So the probability of an event, this kind of gives you an idea. Stuff you probably would have guessed, but defining it nonetheless. So 50% chance is it's equally likely not to happen as it is to happen. 0% chance is it's impossible. It's an impossibility. I can't flip a coin and get a 6. um, on a two-headed coin, if I flipped it, I'm pretty certain as long as it landed, I would get a head since it's a double-headed coin. But the 50% coin flip is the theoretical probability. And then they want to say that that's unlikely if it's 25%, 75% is considered likely. So if it's 75% chance of rain, it's likely. Okay. Now, so down here it talks about that, and I'll let you pause and read that if you like, but I kind of just put that in there for you. Okay, now relative frequency is going to be what we're going to talk about here in a minute, which is experimental probabilities. Experiment, in other words, using an experiment. So the total number of times you flipped the coin over the number of times you got a head, or they show this example, which is kind of fun. You're flipping the bottle and trying to land it. Well, it looks like they did it 25 flips and only got 2 to land. I know you all could do so much better. So you end up with 2 over 25 or 8%, because when you divide 2 divided by 25, you get 0.08, and that becomes 8%. So 8% falls in the unlikely category. Not impossible, but unlikely. Okay, so now we're going to talk about 7.2, which introduces the idea of theoretical probability versus experimental probability. And guys, this is very simple, okay? It's experimental is a probability you come up with based on an experiment, or the relative frequency, as we talked about earlier. So you conduct an experiment. As you can see over here, this experiment wasn't so good. He flipped the coin here 25 times, and only heads was spun. Okay, I didn't know you could spin a coin, but anyway, heads was 6 out of 25, therefore it was only 24%. So, pause the video if you want to, I want to see if your brains are working here. What do you think the theoretical probability? Think of the word theory, like theoretically, I should have gotten what? How many times should it have flipped over? Hopefully you thought that the theoretical probability would be 50%. Because there's a head and a tail, they're equally likely to land on one another. So in an experiment, the more frequency, the more number of trials that I do, the closer to a theoretical probability I should come. So that's it. And 7.3, we'll talk about some more difficult stuff like compound probabilities. So that'll be the next section. All right, we'll see you then.